All right, I'm going to begin, I think, in section 4.3. I'm going to start with an example to explain what we're trying to do. I want to start by sketching a graph of 2x minus 5y equals 10. Now, when we do this, we typically make an XY chart. At least that's what we've been doing. And I'm only interested in a couple of very specific values for x and y. When x is equal to 0, if I replace x with 0 in this equation, I will end up with negative 5y equals 10. Solve that equation for y, and you'll end up with y equals negative 2. Similarly, I'll now let y equal 0 and replace y equals 0 in this equation, and I'll get 2x equals 10. So x will be equal to 5. Now what I want to do is sketch a graph of that. I'm going to graph these 2 points. So let's see. This thing is a little bit different than I have in the classroom, so things are a little bit different looking. Let's see how this goes when I go to put it in. That doesn't seem so bad. And let me graph these points. So 0, negative 2. If I start at the origin, I simply go down 2 units to get it. Put a dot there. And then 5, 0. Starting at the origin, I'll simply go 1, 2, 3, 4, 5 units to the right. And let me go ahead and connect those 2 dots with a line. Try to be as careful as I can. You should be trying to do these with your own graph paper by hand. That's the only way you're going to get a good feel for these things. And I'll extend this one the other way. So I want to make sure I get my points. The location of my points was not exactly exact, but nonetheless. While I'm here, I'm going to remind you this point right here was 5, 0. This point down here was 0, negative 2. And, oh, all right, this thing right here is called the X-intercept. I think these words are words you should know, but this guy right over here, that's called the Y-intercept. But that's just to remind you of those things. I'm more interested in this line and how it is angled upward. Notice if I start to the left, let's start at this point here. If I start at this point and then go to the right, notice that I'm going up and to the right at the same time. I would like to describe that steepness. So is there a way to describe the steepness? And we do have a way. The slope of a line describes its steepness. So how do we define that? Well, what we do is pretend like you're starting at the left point. What I want to do is starting at this point, I want to go over and get to this point, but I'm not going to follow the line to do it. I'm going to stick to the grid. So pretend you're walking along sidewalks, right? You're starting at this point. I can't walk through the grass. So starting at this point, in order to get from this point to the other one, I have to go up 2 units first, and then I turn right and go to the right 5 units. So the slope of a line is given by this equation. The letter m, for unknown reasons, is used for slope internationally. What we do is we define it in terms of something called rise divided by run. So if I started at 0, negative 2, what I would do is first go up 2 units, and then I would go right 5 units. Now, when you're talking about a vertical line, upward is positive and to the right is also positive. Downward and to the left are considered negative. So my slope in this case is just 2 divided by 5. determine the slope of the line 4x plus 3y equals 12. And I'll do exactly what I did last time. I'm going to make myself an x and y graph. And you get pretty good at doing these after you've done a few of them. But once again, I'll start with x equals 0. When x is equal to 0 here, we're solving 3y equals 12. So y equals 4. On the other hand, if I start with y equals 0, zero this part of it out, I'm left with 4x equals 12. And so x is equal to 3. So there's the 2 points that I need. Let's go ahead and draw in my axes. And let's go ahead and put in 0, 4 would be my y-intercept. How do I get there? I start at the origin and I go down 1, 2, 3, 4 units, and I'll put a dot. Then the 3, 0, the x-intercept, starting at the origin, I will go to the right 3 units and put another dot. Now if you want, you can try and put a third dot just to make sure you're doing things correctly. Let me go ahead and connect these with a line. I just realized I did this wrong, didn't I? When 3y equals 12, so my dot actually, my first dot shouldn't be 0, negative 4. It's 1, 2, 3, 4. It's actually up here. That's my bad. So let me fix that line. Let me fix that. I think I got 1 point locked down. There, I might have it now. You, of course, can always fast forward through this stuff if it bores you to death. All right, now you can see the slope is slightly different than before. It's not going up as you go to the right from one point to the other one. This time, as you start from this point here, that was what, 0, 4? And you proceed to 3, 0. This time, you are going to the right, but at the same time, you're going down and then to the right. So for a situation like this, we call the slope negative. We attach the negative to the numerator. So I'm going to go down 4 units. So I'm going to say that's a negative 4. But then I'm going to go to the right 3 units. So this is a positive 3. Keep this in mind. You will never, ever, ever, go to the left. You'll always only go to the right. But you'll go up or down, so that'll be positive or negative. But you'll only go to the right after that. I think I want to do a note or two here. So let me go ahead and throw in a grid. Try to get it on there. It's supposed to lock into place. Okay, so let me draw any kind of a line on here. It could be nondescript. There's my line. Now, what I would like to do is come up with a formula that gives us this slope. So suppose I start from one point, x1, comma, y1, and x2, comma, y2 for the second point. Now what we're doing here is we're first going to go straight up from this point. So we're going to go up. How far, I don't know, but then we're going to go to the right to get to the other point. So let's take a look at the distance here. Let me label the y values. Here's how you get them. Take this point and go immediately to the left of that point, and guess what? The number on the y-axis is that number y2. Do the same thing here, starting with this point, and immediately go to the right, and I have y1. I can get the x values in the same way. I can start at this and then go straight below and get x1. And then the same thing here, I can go straight below and then get x2. So if you look, what we have here is a little bit of a triangle. Let me see if I can sort of make it up. Try to be as similar to that thing as possible. What we had here is the part, if you look at the distance, this length here, it'll be the bigger number minus the smaller number. So that's why I get the y2 minus y1. Similarly, if I go across, I'm going to take the bigger number minus the smaller number. So that's x2 minus x1. Well, slope is equal to rise over run. The rise part is this part right here, the vertical part. Y's control the vertical. So we'll have a y2 minus y1 all over x2 minus x1. And then this is the formula I want to use for some of the next computations. So let me use this formula in an example. Let me keep that up while I make this example. We have, let's determine the slope of the line negative 4x plus 5y equals 20. So we'll do the same thing. I'm going to make myself an XY chart. And I'll start with x equals 0, then I'll let y be equal to 0. You know the deal. So if we start with x equal to 0, then I'll have 5y equals 20, so y will be 4. And then when y is equal to 0, this 5y will go away, and we'll be left with x is equal to negative 5. So I have 2 points. Some of the points that I have, I'll get from the chart. I have 0, 4, and then negative 5, 0. Now what I've seen students do in the past is they'll commonly list these things above the numbers that they know what to use in the formula. Then when I go to do my m, my slope, I'll do y2 minus y1 divided by x2 minus x1. And so my y2 was equal to 0, my y1 was equal to 4, my x2 was equal to negative 5, and then my x1 was equal to 0. So I will get a negative 4 divided by negative 5 will be a positive 4 over 5. Now that means you're going to be going up 4 for every 5 that you go to the right. So you ought to take a look and get used to or comfortable with the way slopes look. Like if I see a line that goes something like this, this would be a positive slope because you're going up and then to the right. For this one, this would be a negative slope. Because now you're going down and to the right. And then a couple of unusual lines, horizontal lines. Are a little bit different. Let me draw a real quick picture of one of these things. I don't know if I've talked about the equations that will give these or not, but I can always talk about that now. It's no big deal. So let me go ahead and draw just a quick little thing in here. So a horizontal line will just go straight across, as you can imagine. Let's draw this. Let me see if it'll snap to the grid as well. It looks like it's doing a right job. Now let's put the point that it intersects the y-axis on there. So I'll call it 0, b. So the line y equals b is a horizontal line. This is what the equation is. There's no x's involved in the equation. It's just y equals b. So to get the slope, let me take another point that's on this line, and you'll notice it's the y value is still b. I don't know what the x value is, but let's say, let me see, 1, 2, 3, 4, and then here we have 4, b. So then when I do my slope, I will have y2 minus y1 over x2 minus x1. y2 is equal to b, as is y1, so you get b minus b. And on the bottom, you'll get 4 minus 0. I don't really care about that. You'll get 0 over 4. The most important thing is that you'll get a slope equal to 0. So that's for horizontal lines. For vertical lines, let me draw another one of these things. A vertical line, well, you know what vertical looks like, will just be up and down. Let me draw how well I can draw a vertical line and see. That looks close enough. So here, you'll cross at something like an a comma 0, and then let me pick another point, maybe this point up here. Here, for the x value will still be a, but the y value will be 2, it looks like. So then when I do my slope on a vertical line, y2 minus y1 over x2 minus x1, my y2, I can use this 2, and for y1 I can use 0. But for x2 and x1, they're both whatever this number a is. Well, you can't divide by 0, so the slope is undefined. And it's because of dividing by 0. So these two lines, you'll find it's easiest just to keep them memorized and keep them in a separate category to all the other lines. Now, what I'd like to do also is grab some homework problems from the textbook to show you how they work in terms of this graphing. It'll look a little bit unusual, so let me pop over to Alex. And let me go ahead and log in. And I want to look at the homework for sections 4.3 and 4.4. So we will go to assignments. And we'll preview 4.3 and 4.4. So I've outlined is that I would like to do problems 2 and 3. I think they'll be useful to us. So let's start. Well, hey, while I'm here, this happens to be showing here. Determine whether each slope is positive, negative, 0, or undefined. So if you look, this is a vertical line. I just said it's undefined. A line that goes down as you go from the left to the right has a negative slope. A horizontal line has a 0 slope, and then if it goes up, as you go from right to left, it's a positive slope. Let's go ahead and check my answer, and I think I got them. All right, well, that's taking its time to check. I may have to come back to that one. Will it let me choose another one while I'm waiting? Negative. All right, let's go back to this thing then. Let's close this and try again. Oh, they're not all going to be this. Well, you saw what I did, so whether it marks me right or wrong for that particular answer, I don't care. I'll go on to number 2. My feeling is, though, it's not going to let me do anything here. All right, so for this thing, we want to find the slope of the line graph below. So let me go ahead and copy it. And bring it into our lecture. All right, let me go ahead then and list my points. For this point here, I have -2 for x and 1 for y. So I have -2, 1. For this other one, you can read them right off. 2 for x, 4 for y. So we have 2, 4. And as I see my students do, I'll do an x1, y1, x2, y2. It doesn't matter which one you call the 2's and which one you call the 1's. Just don't mix a 2 with a 1 and you'll be okay. So our slope then will be y2 minus y1 over x2 minus x1. So y2 was 4, y1 was 1, x2 is 2, and x1 is -2, so minus -2. You should be able to tell that this line has a positive slope just by looking at it. So the top is 3 and the bottom is 4. Now, so the slope is 3/4. Can I check? Well, let's find out. It has, you can just type 3/4 and check. See what happens. Yay, I got it right. Okay, let's go back to this first one because it's haunting me. Once again, horizontal is 0, vertical is undefined, line 3 is positive, and line 4 is negative. Just like they're pretty much the same thing. All it's going to do is move them around on you. Yay, I got it. Okay, now let me go on to number 3. Now, this one is just to find the slope of the line passing through those points. So there's no graph given. They just want you to use the formula for this one. So let's slide up. And just like class, these things come in tiny. I'll make it bigger and then work from there. Let me put a little demarcation here. All right, so I'll do the same thing I did. x1, y1, x2, y2. m will be y2 minus y1 over x2 minus x1. Let's see, my y2 is negative 4, my y1 is 5, my x2 is 8, and my x1 is 2. So in the numerator I get negative 9, and in the denominator I'll get a 6. You could simplify these too. Something that goes down 9 units for every 6 over, well, it also goes at the same rate as negative 3 or 3 units down and 2 units over. So it actually does simplify. Now let me move on to section 4.4. 4.3 is rather simple. Hopefully it's a rather easy section. Let me see the name of the textbook. Well, not the textbook, but let's go into here. And come here, textbook. Chapter 4. All I want to do is see what the name of this thing is called. The slope-intercept form of a line. And let me go ahead and draw a picture here to sort of motivate what we're going to be doing. Lines, we have several ways of describing lines. This one is probably the one that's most useful to students, I imagine. And let me just draw a nondescript line in here, but I'm not going to really label anything except for where it crosses the y-axis. So let's say I have a line that goes through like this, and it crosses, let's say at this particular point that I'll call 0, b. Now, on the other hand, let me pick just any old point x, y. All right, so this 0b is like my x1 and my y1, and this over here is like my x2, y2. So let me get the slope. M equals, so I'm going to use y for y2 minus, and then I'm going to subtract b. Similarly, I'm going to use x for x2, and I'm going to subtract 0. So what happens then is m equals y minus b divided by x. Now I'm going to multiply both sides of the equation by x. So I get mx equals y minus b. Better yet, y, if I add b to both sides, will equal mx plus b. The beauty of this, and we'll do some examples obviously, but the beauty of this is if I know the y-intercept and the m is told to me, then from this point I'll know how to go up and to the right based solely on the slope. So once I have that point in place, the slope will help me graph the line. Let's do an example. The example I had in mind was located in the homework problems, problem number 5. We want to graph this. Well, let's go ahead and put it in. I think what I'll do it on my graph paper and then do it in here to show you how it works. So let's pop over back to my notes. Maybe make sure that you don't confuse it with the previous example. And now let's go ahead and draw in my axes, and then we'll draw a line. This has got to be probably the easiest way to do one of these things. So let me move up. Do I have enough space? Okay. So what I have is the slope is 4/3. M equals 4/3. Rise is 4, goes to the right by 3. The y-intercept is at -7. So, let me fix my graph here. So it is on, it's supposed to snap to those things. Good. Anyway, so I got to start at 0 and go down to -7. 1, 2, 3, 4, 5, 6, 7. Let me put a dot. Got it. So that actually is not -7, but 0, -7. So they say y-intercept -7, they mean 0, -7. Now what I'm going to do is use this slope. I'm going to go up 4 units. 1, 2, 3, 4. A little mark here. So up 4. And then from here, I'm going to go to the right 3. 1, 2, 3. So this will be my stopping point. Right 3. Now, all I got to do is take a line and connect these 2 points. Takes a lot of finagling to get these to come out right. And see, and then when you let off the mouse, it does some stupid stuff like that. So anyways, there's my point. So all I needed to know was the y-intercept and the slope, and it was able to generate a second point for you. Now, to do it inside of the homework, I believe we do exactly the same thing. So we start, let's see if I can put, what's this here? I think this will plot a point anywhere. So enter the x and y coordinate of the point. So I'm going to put 0 and -7. So let's see if it'll plot it. It does. Do you see it down there? Now, do not approximate, for example, right 1/3. Okay, I understand that. I've got that. Now let me see what this line does for us. I think we put 1 point here, click, and the second point, here's what we're going to do. I'm going to go up 4 units, 1, 2, 3, 4, and then I'm going to go to the right 3. 1, 2, 3. Click. And when you have those 2 points in, you're okay. Let me go back to mine. Let me put what this point was, by the way. We had for the x value, it was 3, and for the y value, it was -3. 3, -3. Let me go back to our homework, and let me see if 3, -3 is on there. So here's 3, come down to -3. It looks like it works out, so I am ready to check. Good. Now I want to move on to problem number 6. So remember, if you have the intercept and the slope, you only need those things to graph it. You're going to be able to graph the y-intercept and then use the slope to generate a second point. I want to do problem number 6 as well. Now we want to graph the line with slope 1 passing through that point. So let me go ahead and do that. Now they tell you the slope, but they don't give you the y-intercept. They give you some other point. Well, that doesn't matter. As long as we have any point, I can go from that point and use the slope to generate a second point and then graph it. Let's go ahead and draw a graph in this. I'll show you what I'm talking about. All right. Now, let's start with the point, -1, 1. So on this, -1 will be here for x, so I'll go to the left 1, and then I'll go up 1 unit to get my point 1, 1. So 1 for y, -1 for x. Now the slope, the m that they give you is 1, but it's best to think of it as 1 over 1. So what I'm going to do, to graph another point, I'll go up 1 and to the right 1. Now if you're doing this by hand, I hate how it does that, but if you're doing this by hand, it's best to use small dots and to graph and connect points that are far away. I'll show you as I'm doing this what I'm talking about. You can reverse your steps going the other way too. If you reverse your steps, you're going left and then down 1, or down 1 and to the left. But I think I've got enough points. So let me go ahead and draw a line through all these things. And I'll connect it from the last one that I did all the way as far as I can to the first one I did. The reason why I do this is because once you get these points in, everything in between will fall into place. Let me see if everything worked out. And so there you go. You get, oh, by the way, you can tell what the y-intercept was from this. So let me go back to the homework and see if I can get it to do that. So once again, I think, what is this? Is that plotting a point? I think -1, 1. Nope, I was wrong about that. Well, let's grab this guy then. So -1, 1 will be my first point. Click. And then I want to go up 1 and to the right 1. And let's check our line out. There we go. Moving on. I'm just going to do a bunch of these. There's really not a lot for me to explain except while I'm doing the problem. So let me move into 8. See how close it will get it to here. Now, remember I said there was a form of the equation of a line that was like this, mx plus b. There's a name for it. It's called the SlopeIntercept Form. The reason why it's called that is because the m, well, that's the slope, and the b tells you what the intercept is. So you want to look at this and see if it's in. You want it to be y equals mx plus b. Well, look, I'll write underneath the same thing, but I have -1/5 x plus 6. Well, you can just match them up. The b even looks like a 6, doesn't it? So my m is -1/5, and my b is equal to 6. Let's see what they have for the homework, what you need to put in here. So my slope, oh, it's easy. -1 divided by 5. Tab my way, and the y-intercept, technically it should be a point, but I don't think it's going to allow it. I'll just put the number 6 and see what happens. It should technically be 0, 6, but let's see what happens. It gives me a correct answer. So I'll accept the same from you as well. You don't have to tell me it's 0, 6. Just the number 6 will be fine. So long as you can locate it on a graph, that's all I really care about. All right, on to number 9. Find the slope and the y-intercept of the line. Check this out. What you're going to do is we want y equals mx plus b. If I can do that, then I can get the slope and the y-intercept all in one. Well, all you have to do is take the equation. So start with the original equation. And then solve for y. That means isolate y. So pretend you're solving this equation and you're trying to find out the value of y. Well, the first thing you would do is probably subtract this stuff off. So I'm going to subtract 3x from both sides. Now, I can't combine the 16 and the 3x, but I'll write it in this format. Minus 3x minus 16. And on the left, we have negative 4y. Now, the next thing I'll do is divide both sides by negative 4. Now, I want you to recall something. If you have an equation or you have a fraction that's like this, you're allowed to break it into two pieces as such. Both fractions will both have the same denominator. I'm going to do exactly the same thing here. I'm going to write it as negative 3x over negative 4 minus 16 over negative 4. And then I'm going to simplify it. Let me just put a y over here. The negative 3 and the negatives will cancel, and you'll get 3/4. I prefer to put 3/4 first before the x. And then here, these negatives will cancel, and you'll get plus 4. So the slope is 3/4, and the y-intercept equals 4. Well, let's go ahead and put those in the book. So all you had to do was solve the equation for y. Let me throw those in. Slope was 3/4. And the y-intercept, what was that y-intercept? I don't even remember. I saw it 2 seconds ago. Was 4. And let's check ourselves. Good job. All right, moving on. Number 10. I'm going to have to turn that thing off. It drives me up a wall. No different than a cell phone going off in class, I suppose. Let me do an example. All right, so the equation of the line is given. Find the slope and the y-intercept and then use them to graph the line. Here is where the real power of the y-intercept becomes evident. So we'll start with negative 4x minus 3y equals negative 12, and you're going to want to solve for y. The first thing I'm going to do is multiply both sides by negative 1. That's annoying that everything is a negative like that. And I'll get 4x plus 3y equals 12. Now, in order to find the slope and the y-intercept all at once, I will solve this equation for y. So I get 3y equals negative 4x plus 12. And then I'll divide by 3. Now, as I mentioned before, it's smart to break that fraction up into negative 4/3 x plus 12 over 3, but that will be equal to 4. And so right off the bat, I can tell my slope, which is negative 4/3. And the y-intercept equals 4. So let's throw those in. I think they want more from us than just that. So negative, I can't believe I can't remember negative 4/3 and positive 4. So negative 4/3 and positive 4. I see they don't check. It doesn't let you check parts of the problem as you do it. It's either all right or all wrong. Now, here's the beauty. The y-intercept is at 4, so I can take and put a point. My first point is at 0, 4. Let me click it and put it in place. So there it is. Now the negative 4/3 tells me how to get my next point. The negative 4/3 means you're going to go down 4 units, 1, 2, 3, 4, and then you're going to go to the right 3 units, 1, 2, 3. Click it, and let's check. Correct. So this gives you an idea of how you can use the equation itself to graph the line. All you got to do is solve the equation for y. In fact, the y-intercept form, the slope-intercept form, is probably the form that most people find the very most useful of any type of form for the line that there is. Now let me move on to parallel lines. I wasn't aware before I started teaching this class that there are people who come to college and they don't know what parallel means, oddly enough. But what you'll have is a situation like this. I don't care what version of parallel you try to memorize or what you think. It's two lines that will never intersect each other, ever. So parallel lines never intersect. In fact, there's more to it than that. If you look, the steepness of this line is exactly the steepness of this line. So they rise and run at the same rate. So they have the same slope. And then perpendicular lines look like the following. Well, I'll have one come in and do something maybe like this. The other line will come in. I can't draw it very well, but you've probably seen these little squares they put in here. They intersect at right angles. Or if you want, they intersect at 90 degrees. I really don't care. Whatever it is you want to think of it as. But they definitely do intersect. So parallel lines never touch. Perpendicular lines definitely do intersect. So these have the same slope. This one here might have a slope of m, but this other one has a slope of negative 1 over m. So keep that in mind. Here, m, m. Here, m, negative 1 over m. So we're going to do a couple of examples to illustrate how you can tell when lines are parallel and perpendicular based on their equations, not necessarily just on their graphs. So let me do an example. More textbook problems. I want to grab problem number 11 from the textbook. You got to watch when it does that to me. Let me grab problem number 11 from the textbook. And this will be pretty, this one I hope is a very easy one to start things off. All right, we have the line y equals 7x minus 3. They were kind enough to put it in slope-intercept form. So we already know what the m is. What is the slope? Well, what's the slope of this line? Let me put it here. M equals 7. It's sitting right there in front of the x. So what is the slope of a line parallel to this line? As I said, 7. What is the slope of a line perpendicular to this line? Negative 1 over 7. And that's all there is to it. Let me go ahead and check my answers. 7, tab, negative 1 divided by 7. Beautiful. Moving on to 12. So this is the same kind of a question, but now it's been asked in a slightly different format. We do that a lot in math, and that's probably why students get so upset when problems don't look like they have for homework. But us as professors will be like, oh, no, it's the same kind of problem. The words are just a little bit different. That doesn't mean a lot to us, but to students, I can understand it means a big deal. So let me go here. Now, it's asking me the same two questions. Give me the slope of a line parallel, and what is the slope of a line perpendicular? So if I want to know the slope, so let me start to get the slope. Solve for y. Because what that'll give you y equals mx plus b. Once you solve for y, you're automatically in this slope-intercept format business. So start with 2x plus 7y equals 2. And I'm going to subtract 2x from each side. So my 7y will equal, the way I like to write this, since I'm anticipating a slope-intercept form, is I'll usually put the x's first. Now then, let me divide by 7. And remember, you'll find it easiest if you break this into pieces. Negative 2/7 x plus 2/7. So, any line that is parallel to this has this slope. So any line that is parallel will have a slope of negative 2/7. Remember, so the magic format was this one. What is the slope of a line perpendicular to that? Well, like I said before, it's negative 1 over m, or another way to look at it is take the negative reciprocal of this thing. So what's the negative reciprocal for perpendicular? Negative 1 over m is the same as the negative reciprocal of m. So in the case of the line perpendicular, then the negative of a negative, that'll go away, and you'll be left with 7 halves, positive 7 halves. So let's go ahead and throw those numbers in and see if they're right. So I have negative 2 over 7, and then we had positive 7 over 2. Let's check. Looks good. Now I think I want, let me see, number 13. Let me take a look, gander, how much more I wanted to do. Oh, this is the last one. So, oh, this is a beautiful example, exactly what I wanted to sort of go and use as what do you call it? A capstone example, one that sort of illustrates everything at once. Unfortunately, I see that they're not all in y in the slope-intercept form, so I'm going to have to do some work on this. So let's go ahead and bring this over to our page. And then let's go back to here, move you up. Sample. Alrighty. Well, in order to get the slopes of these other lines, I'm going to solve each of these for y. So let me go with line 2. We have 5y equals negative 3x plus 4. Let's divide both sides by 5. Y was almost solved for. And so we would get y equals, it looks like negative 3/5 x plus 4/5. So I have that, so I know my slope here is negative 3/5, which matches line 1. So line 1 and 2 are parallel. All right, let's move on. Line 3. Here, 10x minus 6y equals negative 6. There's a little more work to do than I had to do before. Let me subtract 10x. And so I have negative 6y equals negative 10x minus 6. And let me divide by negative 6. And so y will equal 10 sixth x plus 1. It's probably not a bad idea to simplify this because you may not, the 3 over 5, you'll see if it's in simplified form. You don't see it here until you simplify and get 5/3 x plus 1. So this one's slope is 5/3. Well, let's take a look here. The slope of both line 1 and line 2 is negative 3 over 5. Well, this is the negative reciprocal of those lines. So line 3 is perpendicular to lines 1 and 2. Remember, 5/3 is the negative reciprocal of negative 3 over 5. So what I have then is line 1 and line 2 are parallel, and line 3 is perpendicular to both of those lines. So let's see what answer boxes. This looks like checks. Line 1 and line 2 we said were perpendicular. Line 1 and 3 were perpendicular. I'm sorry, line 1 and 2 were parallel. Line 1 and 3 were perpendicular, as was line 2 and 3. So, oh, wait, I don't use my pen. I'm going to use this thing. And let's check. And we are all done. So hopefully the first lecture wasn't this horrible thing. They go faster here because, well, I don't walk around the room. I just kind of go from one thing to the next. Nobody is stopping me to ask questions. But don't forget, at the bottom of the page, look underneath look where it says comments below this, what you're seeing on screen. And that's where you can write your homework problems. Do me a favor and list for me the problem number and the section that it comes from so that I'll be able to find it easily.